Hi, everyone. It's 1 o'clock, so we can get started. Welcome. Thanks for coming in. This review session is just going to be very up to you guys and what you want to see. Just very informal and tailored toward the questions you have for the upcoming quiz 2, whether that be Tuesday if you're in Dr. Altamos's class or Wednesday if you're in Dr. Altman's class. So with that being said, are there any specific questions or topics that we want to go over? Practice problems or something like that. You can just unmute yourself or write it in the chat so that I can see.
Can you go over titrations?
Yep, absolutely. Anything specific about titrations?
Not necessarily, just in general.
Just in general? Yeah, absolutely. Okay.
Thank you.
So if we're looking at titrations, can someone tell me what it means to do a titration or what is a titration? Anyone know? Have you done a titration in lab yet? I don't remember when that comes around. But with titrations, so titration is going to be the neutralization using a titrand and a titrate. Important things to know about titrations is we have the equivalence point. Can anyone tell me what they know about the equivalence point? What happens at the equivalence point?
When neither are, well, both of them are limiting.
Yep, so both of them are limiting, or we can also say, or another way to say that is that the moles of acid and base are equal, right? So you don't have extra acid or you don't have extra base. You have the same number of moles of acid and base. So for a strong acid and strong base titration, what is the equivalence point pH? What is the equivalence point with a strong acid and a strong base? Throw out any number.
Would it be 7?
It would. Yep, perfect.
Okay.
Yep. So for a strong acid and strong base, your pH is going to be 7. It doesn't matter what strong acid you use. It doesn't matter which strong base you use. It doesn't matter the concentrations of either one of those. It just matters that the pH will be 7. We can figure out how much of each one that we would need, but your pH will be 7. If you have a strong acid and weak base, your pH at equivalence point is going to be acidic, which means anywhere from 0 to 7, probably in that 4 to 5, maybe 6 range. And then if you have a weak acid and a strong base, your pH at equivalence point is going to be basic, which is anywhere from 7 to 14, usually, probably around that 8, 9, or probably like 9, 10, 11 range. Okay. But always at the equivalence point, the moles of your acid is equal to the moles of your base. So if we are given a question where it says, Sorry, my oven is going off. Think about this question as I turn my oven off. Ready? Sorry about that. Okay, so for this question, we said a 0.1 molar acid is titrated with 0.25 molar base. At equivalence, 0.25 mils of base was added. How much acid did we have? Right, so we want to look for that initial volume of acid that we started with. Does anyone have an idea of how we would start this question? What do we know about concentration? What do we know about volume? What can we solve from there? Any ideas? Okay, if there's no ideas, so one thing that we need to know is that, right, moles of acid equals moles of base. In order to get moles, we're given concentration of acid. So we have 0.1 molar, which is 0.1 moles over liter. In order to get to moles of acid, we need some sort of volume component. But we don't know what that is, so this is our X value that we're looking for. But on the other side, we're given concentration of our base, and we are given a volume for this. We're given 25 milliliters. Do we need to convert our milliliters to liters in this case in order to solve for our volume of acid? Looking at our units or looking at what we might need to solve for. Do we need to?
Yes.
Okay, so you actually don't. It's kind of a trick question that I like to give. In this case, right, if you wanted to cancel out your liters, you could. You could totally change this to 0.025. But if we solve this directly as it is, then our answer will come out in liter or in milliliters. If you keep track of your units along the way. If our value or if our question asked us for the answer in liters, then I would recommend changing your units. But in this case, since we're just looking for a straight up volume and it doesn't give us units directly, we can just use the milliliters and everything else will cancel out. Because if we look at moles over liter and moles over liter, those will cancel out. And then you're just left with milliliters and milliliters. So in this case, you don't need to change your units. So in order to solve this question, we just need to multiply 0.250 times 25. And we get 0.1 times x equal to 6.25. Technically, moles times milliliters over liter. We can divide by 0.1 on both sides. And we are left with X equal to 62.5 milliliters. And in this case, right, our moles over liters would cancel out and we're just left with milliliters. So we started with 62.5 milliliters acid. What questions do we have about solving this question?
These types of problems, I always end up switching the numbers around. Like I never put the brackets numbers where they're supposed to go.
Okay, so let's look back at the original question. We'll kind of, because I still do this when I'm solve questions as well. I did it a lot when I was in undergrad solving these types of questions. So whenever I see a question, if you're given to it on like a piece of paper, or you're writing it down, and then right, because you're going to take it on your computer for the quiz, I will always circle 0.1 molar acid, and I will say this is concentration acid, right? And so I label exactly what that value is telling me. I'll then do the same thing for our base. So I'll say this is my concentration of my base. We say at the equivalence point, 25 mils of base was added. So I'll circle this and I'll say volume of base. And how much acid did we have? I know that how much acid, right? How much acid? This is looking for volume acid, which is X. So now I look at my numbers and I say, okay, I know my base stuff always has to stay together and my acid stuff always stays together. So now I can plug in what I know to each of my points in my equation, and then I stay a little bit more organized as I'm setting up that initial formula that you're using. This will come really helpful if you start doing this and like annotating your question when you get to like gas laws, because there are a lot of variables come into play and it's hard to keep track of all of them. So writing like what that variable is directly is very, very helpful for staying organized. Does that help you a little bit with putting those numbers together?
Yes, it does. Thank
Okay.
you.
Yep. And then in terms of topics that you should focus on for the next quiz, I don't know what the breakdown of the quiz is in terms of like what's like what types of questions are being asked for which topic. But I believe anything from quiz one, like the material you learn from quiz one to quiz two is fair game. So that I think that's like 5 days of class if you're in Monday, Wednesday, Friday, and 4 days of class if you're in Tuesday, Thursday. But I think the big things are going to be stoichiometry and limiting reagent, maybe a little bit of acid bases. Your solubility rules are going to be very, very important. And like net ionic equations, being able to predict your products, all of that stuff is going to be probably what's hit heavy because we focused a lot of that on both of them. And I don't think and like combustion analysis, I would say would be probably a good topic for quiz two as well. If that helps answer your question. If there's anyone else that has like more insight into that, let me know too. Happy to do that. How do you feel about titrations? A little bit better on that one?
Yes.
Okay. And then you can go back to this question and you can ask yourself a different way, like maybe change the value of one of your concentrations, and then maybe give yourself a volume started and try to solve for a different concentration, right? Change with the numbers a little bit. And then you'll be able to, and then you can kind of make your own, come up with your own questions. Or you can just look up like titration practice. And that can give you some extra questions as well. So for Natalie, for your titrations formula, it looks very similar to M1V1 is equal to M2V2. But for titrations, we sometimes write this as MAVA is equal to MBVB. So you have your concentration of your acid times the volume of your acid equal to the concentration of your base times the volume of your base. You always have to be careful with titrations on monoprotic and diprotic acids or bases, right? If you have two protons, right? So for this strong acid, this means that you now have two chances for your base to interact with your acid. And so in order to account for this 2 moles of base, you're going to change this so that your acid is divided by 2 because now you have 2 moles, right? So you have 2 extra. So in order to get rid of that 2 to get down to the 1 mole of your base, you're going to divide by 2 to get to 1 to 1, right? So you're going to divide by how many acid or how many protons you have in your acid. Don't worry too much about that. I think they're going to stick to mostly monoprotic stuff, but just in case you do see a diprotic acid, just know that you have to change your formula a little bit. Do you want to do another titration problem or do we have more questions? Okay. Let's do. Let's do. Okay, so for this question here, we have 25.3 mils of HCl are needed to titrate 22.5 mils of 0.118 molar ammonia to the equivalence point. What is the concentration of HCl? I don't know, I had a brain fart there. Okay, so let's kind of, I wonder if, sorry, I was trying to think of something. All right, so let's annotate our question. When we talk about 25.3 mils of HCl, what is that referring to? Good. Yep. So this is our volume. And is HCl going to be our acid or base? Good. Okay. What about 22.5 mil? What does that relate to? Good. This is volume, base. And then lastly, we have 0.118 molar ammonia, NH3. What is this one? Good. This is our concentration of base, right? So we're going to write our formula. So we have MAVA equal to MBVB. That's a great question. So HCl is one of your 6 strong acids. I believe she will tell you if it will be a strong acid or a strong base, but I recommend recognizing the strong acids. There's only 6 of them, and HCl tends to come up more often than not, I feel like. So the more you work with these types of questions, the more you'll realize that HCl is a strong acid. But I think she will tell you if it's a strong acid, but definitely HCl is going to be a strong acid, and it's because it has this extra proton here. This H is indicative of an acid. NH3, you'll come to realize if you keep on moving on with chemistry, is that this becomes a weak base. A lot of things with nitrogens tend to be bases, and they tend to be weak bases. And that's, again, something that she would tell you, or something that you'll come to recognize as a weak base the more you do chemistry stuff. But I highly recommend, and you don't need to ever memorize any weak acids or bases, but I do just recommend like putting it in your brain that HCl is a strong acid and kind of remembering those strong acids. It'll just help you later on in the semester as well. So that would be my tip. All right, so we're given our formula of acid equals base, right? And this would tell us that the moles of our acid is equal to the moles of our base. So what value are we putting in for Ma? Do we know what Ma is? Good, we are solving for Ma. So Ma is going to be X. The volume of acid is going to be what we labeled as 25.3. Again, we don't need to convert our units here. We're given concentration, which is 118 molar. And we're given our volume, which is 22.5 mils. Okay, and then we could just solve for X. Which I got as 0.105 molar HCl. Yeah, absolutely. Let me log into the homework real quick. Or if you have your homework handy, can you just like read me a question? I have plenty of limiting reagent ones. I just want to give you one that's reflective. No problem. I'll just log in real quick. Okay. So I'm given this question here. Excuse me. Okay. So we have these two questions here from one of the homework assignments. So it's saying that sulfur dioxide and oxygen gas react together to form sulfur trioxide. And we're given the amounts of moles of each of them that react together. So what we're looking for is what is the formula of the limiting reagent? So in this case, I think my first thing that I would do is if I know what sulfur dioxide and I know what oxygen is, I'm going to write this whole reaction just in our chemical symbols. For the most part, most of your questions are going to be given to you in your chemical formulas. This is just reinforcing that naming thing that we talked about that we didn't fully dive into in class. So for sulfur dioxide, does anyone know what that formula is going to be? Awesome. Yep. We have SO2. And what is oxygen? Good. So it's going to be O2. O2 is one of your 7 diprotic acids, or diprotic acids, 7 diprotic nonmetals. So oxygen in its elemental state will always be O2. Okay, and then what is the formula for sulfur trioxide? Good, right? This is going to be SO3. Okay, so now we have our formulas. So the first thing we want to know is what is the formula of the limiting reagent? So what we have to do is solve for the limiting reagent. How do we do that? What are we given that'll help us solve for the limiting reagent? Perfect. Yep. So the first thing you need to do is make sure that your equation is balanced. Um, so how are we going to balance our equation? Or what part of our equation is unbalanced? Awesome. Yep. Yep. So we need a 2 in front of SO2 and we need a 2 in front of SO3. That makes 2 sulfurs on both sides and 6 oxygens on both sides. Okay, and now we're able to solve for our limiting reagent because in order to solve for limiting reagent, we need to know our molar ratios in our chemical formula. So we're given 0.237 molar sulfur dioxide. What do we use with that sulfur dioxide to find the limiting reagent? Natalie, you actually don't need the molar mass here. We do need our conversion factor though. All right, in our conversion factor, we're trying to find, yep, so John used a conversion factor where you're going to look for sulfur to oxygen. You can also use a conversion factor to look at sulfur dioxide to sulfur trioxide. How I think about limiting reagents is I try to pick a product and then I see, okay, which one produces the least. And if it whatever one produces the least is going to be your limiting reagent. So in this case, I would say for every 2 moles of SO2, I have 2 moles of SO3. But you could also do it how John suggested, and you could say 0.237 moles of SO2, and you could say that 2 moles of SO2 is equal to 1 mole of O2. In the left-hand side, you're asking yourself which one produces the least amount of SO3. In the right-hand side, you're asking yourself, do I have enough oxygen to completely use up all of my sulfur dioxide? Okay, and you would have to do this for both of your reactants. So either if you're doing the left-hand side or the right-hand side, you would need to say, oops, right? You can ask yourself either one of them. Renzo, there's not really ever a difference. I just prefer looking for a product over comparing your reagents. For me in my head, limiting reagent makes more sense to say, okay, which one produces the least amount? And then that one would be my limiting reagent. And a lot of times your questions will ask like how much of this product is produced. And if you solve for it, okay, which one produces the least amount of product, then you're already halfway through your question because you either have already found the grams or you have the moles and you just need to solve for grams from there. So it's just how you think about limiting reagent and what it means to you. Right? You could think of limiting reagent and okay, how much can I use up all of this? Like, what's my least amount of reactant? Or you can say limiting reagent, okay, which one produces the least? In my head, thinking what produces the least is more appropriate for me. But it's just kind of a personal preference. If you use either one of the left-hand side or the right-hand side, then you'll still get the same answer. Okay, so based off of this, which one is your limiting reagent? Awesome. Okay, so SO3, or sorry, SO2, limiting reagent. Because this would produce 0.237 moles of SO3, and this would produce 0.286 moles of SO3. So since SO2 is producing less amount of product, then that is your limiting reagent. Okay, so your first answer for A would be SO2. All right, so then for question B, they're asking, what is the max amount of product produced? In your question, it just asks for moles, like on your homework. So in this case, if you need to find out how much product is already produced, from your initial asking question of what is the limiting reagent, you've already found that moles of product already produced. And so in this case for B, we know that 0.237 moles of SO3 is already our answer. We don't need to do any additional math. Yep, so right, for question A, we asked what is the formula of the limiting reagent. We found the limiting reagent in question A if you use the left-hand side by saying, okay, I have 0.237 moles of SO2. And so in order to see how much is produced, I'm going to say I'm going to produce 2.37 moles of SO3, right? If SO2 is my limiting reagent, I would only produce 0.237 moles of SO3. You're also asking, right, in terms of finding a limiting reagent, we're going to say, okay, if all of oxygen is my limiting reagent and all of that is used up, I would be producing 0.286 moles of SO3. 0.286 moles of SO3 is greater than 0.237 moles of SO3. So the lesser of the two values becomes whatever reagent is your limiting reagent, because if you used up all of that stuff, that's how much could be produced. We can't produce 0.286 moles of SO3 because we would need to have more of that SO2 available to us, but we don't because we're using up all of it already. So when they ask you, what is the max amount of product produced? The maximum amount is if your limiting reagent gets fully used up. And we found that when we asked ourselves, what is the limiting reagent, when we solved for how much product could be produced. Does that help Natalie a little bit? So the stuff on the right side mean, like this portion here, everything in the blue box, this is just if you asked yourself a different way to find the limiting reagent. In this case, right, if you're looking at 0.143 moles of O2. Right, if we're looking at what's in blue here, we're saying, okay, if oxygen is my limiting reagent, then I would need 0.286 moles of SO2 in order to completely use up all of my oxygen supply. But from our question, we know that we only have 0.237 moles of SO2. So because we don't have enough SO2 to completely use up the oxygen, that means that SO2 has to be our limiting reagent. In the other sense, right, if we asked ourselves or we checked for right, if we asked ourselves, if we completely use up SO2, I would need to have 0.1185 moles of oxygen. And we have enough of that, right? We have 0.143 moles. So we have enough sulfur, or we have enough oxygen to completely use up our sulfur, but we don't have enough sulfur in order to completely use up our oxygen. So in that case, that's why SO2 has to be your limiting reagent. That one does confuse me a little bit, and you have to ask yourself the right questions. So that's why I always just form a product, because then I can always compare product to product, and that's easier for me in my head. So if you don't like the right-hand side, you can do the left-hand side. If you don't like the left-hand side, then you can use the right-hand side. Hopefully that's not too confusing. But you can, this is being recorded, so I'll post it afterwards if you need the explanation again. Alrighty, so then we also can look at the excess questions. So we're saying how much excess reagent is left over, right? If we ask part C. Right, so if we ask this question, we know that our limiting reagent gets used up. Okay, so at the end of the reaction, right, when it goes to completion, SO2 is equal to 0, right? We have no moles, no more moles of SO2. But how much oxygen did it take to use up all of that SO2? I kind of just told you that when we checked for our limiting reagent above, right? But we're saying we have this many moles of SO2. I want to know how much moles of oxygen that requires to completely use up our sulfur dioxide problem. So we said that's going to be 1.1185 moles of O2. So that's how much oxygen was needed in order to completely use up our sulfur, right? So now once the sulfur compound is completely used up, the reaction stops, nothing more can happen. So how much is left over is we need to say, okay, I had 0.143 moles of oxygen. I used up this much in order to make my reaction go to completion. So the difference is what's left over. And so this is how much reagent is left in excess. Yep. Then if you need more practice with that, I posted some practice questions, and question 15 on that one asks you a leftover question. That's a good one for limiting reagent too at the very end of that packet. And it's in the office hours tab if you haven't seen it. Alrighty, what other questions do we have? So if we're balancing equations, we can only change the coefficients in front of our compounds. Okay, so as an example, let's do this one here. So we have sodium chloride and fluorine goes to sodium fluoride and chlorine gas. So first question you want to ask is this balanced? Is this balanced? Is this equation balanced? Good, right? This is not balanced. And we can look at this because chlorine has 1 on the left and 2 on the right, and then fluorine has 2 on the left and 1 on the right. So I always like to look at, kind of go left to right in terms of balancing my equation. So for sodium chloride, that comes first. I look at chlorine and I say, okay, there's only 1 chlorine on the left and I have 2 chlorines on the right. So in order to make those balanced, I can put a 2 in front of sodium chloride. And now I have 2 chlorines and I have 2 chlorines on both the left and the right-hand side of my equation. I just put a 2 in front of sodium chloride, which means I've now manipulated my sodium content. I now have 2 sodiums on my left-hand side and 1 sodium on my right-hand side. So in order to balance that, I'm going to put a 2 in front of my fluorine. Now I'm going to check, okay, I say, okay, now I know that my sodium and my chlorine are both balanced. Let me check at my fluorines. I have 2 fluorines on the left-hand side. That 2 that I put in front of my sodium now makes 2 fluorines as well. So now everything is balanced. So our balanced equation here is going to be 2, 1, 2, 1. Right, we can try another question, or maybe we have something a little bit more complicated. Yep. So for this question, right, we have HCl and calcium carbonate goes to calcium chloride, water, and carbon dioxide. So again, same thing. I'm going to go left to right. I see that my HCl, or like HCl is first. I have 1 hydrogen on my left and 2 on my right. So I'm immediately going to put a 2 there because I also see that I only have 1 chlorine on my left and 2 chlorines on my right. So that might help me out a little bit just off the bat. I'm then going to go to my chlorine or my calcium. And I see I have 1 calcium and 1 calcium. So that checks out. My carbons, I have 1 carbon and 1 carbon. And then my oxygens, I have 3 oxygens and then 1, 2, 3 oxygens on my right-hand side. So in this case, this one's pretty simple, and we just needed that 2 in front of HCl in order to make this one balanced. Okay, and then again, on that practice problems that I've posted, I have like 13 different balancing equation ones. So if you need more practice, there are some there, and the answers are posted. Okay, and then what about combustion analysis? Is that like finding the empirical formula? Or what about combustion analysis? Yep. So I have, I think, 3 questions like that too after this one on that set of homework or on that extra set of practice questions if you need more after we go over it. But for combustion analysis, what we're saying is, I can't come up with one on my own too easily for this one. Okay. So when they talk about combustion analysis, you basically have a carbon and hydrogen compound that'll sometimes contain oxygen in it. Well, and the practice questions are under the office hour tab. If you click on office hours above like all the modules, it'll say like Allison's help, and then it'll go by week. So I think it should be the one that says the 7th of February right next to it. But for empirical form, yep, no problem. So for empirical formula for combustion analysis, we always have carbon and hydrogen. Sometimes it'll contain an oxygen, and this will combust with oxygen gas to form carbon dioxide and water. So the whole point of combustion analysis is that all of your carbon that's in your compound will go to carbon dioxide, and all of the hydrogen in your compound will go to your water. So if you're given how much water and how much carbon dioxide are collected after combustion analysis, you can backtrack to find how many moles of your carbon and hydrogen you had in your original compound. So if we're given a question here and it says, okay, and for the sake of time, I'm just gonna kind of walk you through the steps. But you're given something that's a hydrocarbon, which means that there's only carbon and only hydrogen in your compound. So you're going to start off with carbon dioxide, or you can start off with either one of them. I usually start off with carbon dioxide. So I have this many grams of CO2. We don't like working in grams. We need to get to moles. So for every 1 mole of CO2, it's 44.01 grams of CO2. And then in every 1 mole of carbon dioxide is 1 mole of carbon, right? So now we just get down our carbon dioxide to how many moles of carbon are in our sample. So this is this many moles of carbon. You're now going to do the same thing for your water. This time though, in every 1 mole of water, we have 2 moles of hydrogen. So now when we solve this, we get our values of hydrogen in our compound. All right, so in this case, we have 0.0192 moles of carbon and hydrogen in of both of them. Okay, if these were different, you would want to divide by your smallest value of moles. All right, in this case, our smallest value is the same. So it's going to be 0.0192. And this equals 1.0, and this equals 1.0. We need to divide by the smallest value of our moles because we need to get to our nearest whole number for our empirical formula. In this case, these are the same. So your empirical formula just becomes, right, this here now becomes your your subscripts. So now your empirical formula just becomes carbon, hydrogen, because there's only a 1 in both of them. Okay, if it asked you for the molecular formula, they might say, or they say the compound, sorry, not the molecular formula, the compound molar mass is 78 grams per mole. And now you're looking for the molecular formula. You're going to take your carbon hydrogen empirical formula that you found, and we're going to say carbon hydrogen is equal to 13.02 grams, right? Because we took 12 plus 1. And we're going to take 78 divided by 13.02. And this comes out to 5.99. Which we can round to 6. So we need to take our whole empirical formula and multiply it by 6. So our molecular formula becomes C6H6. Okay, are there any questions, or does that help with combustion analysis and how we would solve for those? Okay, great. And like same thing, I have a couple examples of these on that office hour question. I think if I don't know what my Canvas is. So if you go to Canvas in order to solve or in order to find these, if this allows me to load. It might not load. But in any case, on Canvas, there it is, right? I'm in both Dr. Altmos's and Dr. Altman's. So whatever one, it's under the same thing. Under this office hours tab in the middle. And you scroll down a little bit, it's all right here. The answer should be updated. I'll make sure that it's updated. And then the practice problems, and then this recording will also be posted here in a little bit as well. So if you need to go back and watch this video, then we can do that. Okay, but that's where you can find all of the additional practice problems. Alrighty, it is 2 o'clock. So I will let y'all go. I know we didn't get to net ionic equations in the last little bit, but if you have any specific questions on net ionic equations, please just send me an email and I'm happy to answer them as well. And with that, have a great day. Have a great Sunday. You still have some time, so I will be available Monday and Tuesday before you take your quiz in order to ask questions as well. Hope this was helpful, and thanks for stopping in. And go whatever team you want, but go Bills. So